What does function mean? We are going to use a simple example to understand what does function mean. This is a toaster. If you ask people, what is the function of a toaster? What are you actually asking? You are actually asking, what does a toaster do? That's what function means. It means, what does it do? When you ask people, what is the function of a toaster? Someone might answer, it's to toast. Someone else might answer, it's to toast the bread. Are these two exactly the same answer? No. Answer 1 mentions what does it do, but answer 2 mentions not only what does it do, it also mentions what can you send into that machine. This is the input that's allowed to go into a toaster. For a toaster, you can put bread in or you can put a waffle in, but you cannot put your shoes in. We call that the domain. Domain means the set of all the allowable input to a function. That's a very important concept we will learn in the future. But right now, we are only learning the basic concept about function. Here you can see there is a functioning machine here, whatever that is. In our example, this is our toaster. You have to send something into that functioning machine. We call that input. Then this functioning machine will work on that input and get an output. For example, like if this is your washing machine, you put your dirty clothes in there, and after the washing machine, you will get the clean clothes out. Here, come back to our example of our toaster. Look at that. If you send white bread into the toaster, what are you going to get? This is the output. We know what this machine do. So it's to toast the bread. So if you put a white bread into the toaster, you will get toasted bread. And this example, this second one, you have the toaster here, and you see this toasted bread. And what's the input? Then you have to think backwards to figure out what was put into the machine earlier. This third example here, you see your input, that's white bread. You see your output, that's toasted bread. And you do not know what this function do, but you can figure that out from your input and output to know that must be a toaster in between. Now we can see the mathematical example. It's just like our toaster example. You have a math function here, and we will send input into it, and this function will get our output for us. We call the input X, we call the output Y, and this example here, this function, what it does is whenever you have an x sent in, it will add 3 to that x. This f of x is the notation of a function. We'll learn this more detail very soon. But today, I just put it here so you know this represents a function, but mainly this function is just to tell you this function is to add 3 to your input. So now, you know if you send 1 into this function, you will get 4 out. So if I give you 2 problems like this, the first one I give you, I'm sending -2 into this function. What are we getting out? X is -2, -2 plus 3, we will get 1 out. This bottom example here, you know the output is 5, and you know your function is to add 3 to your input. So use the information already give you. You have the output, you know the function, you have to figure out what was that input X. We called this process solving an equation because you are solving that input X. But look at this example above right here, earlier. You know your input is -2. -2 go into this function. What are we getting out? That's not solving an equation. You are evaluating this function value. Remember earlier we spent some time to clarify the words simplifying, evaluating, and solving. Here are 2 examples for that. Now, look at this last picture here. What if you have an input and you have an output, but you do not know what your function really is? Like this example, you have a machine here, f of x. You do not know what f of x is doing. All you see here is the input is 1 and the output is 4. What this machine might be doing, you can see all these possible choices. This machine might be doing by adding 3 to your input. If it's adding 3 to your input, you send 1 in, you will get 4 out. This machine might be doing 4 times your input. If that's what this machine does, 4 times your input, you send 1 in, you will get 4 out. Also, now it might be 5x minus 1. That means you send in 1, 1 will be timed by 5, then take another 1 away, you still get 4. Or it might be 4 up to x power, and when the power is 1, you get 4 out. Or it might be 3 up to x, when x power is 1, then plus 1 again, you get also 4. Or x squared plus 3x. For this one, if you plug in x as 1, you also get 4. You can see many possible choices. There are too many possibilities here. Why? Because you have only 1 point. We cannot determine the function with only 1 data point. Just 1 input-output pair. You see this little circle here? There are different ways to represent this 1 point. Like you can use a table and you'll have just 1 point. You can use a graph, you just graph 1 point there. And you can use a function notation representation. We will learn all this very soon. That's complete our lesson about function. Thank you.